Alright, so the first one, I'm supposed to draw an arrow showing the direction of centripetal force. Centripetal force causes centripetal acceleration, so it is centripetal, meaning center seeking. It always points towards the center of the curve. Now to find the centripetal force, I'm going to use this equation right here. And so I have a 6 kilogram mass going 12 meters per second. Don't forget to square it. Divided by the radius gives me 216 newtons. Now, if the centripetal force was doubled, at what rate would the mass accelerate? This would probably be a good equation to use right here. Look, it's just F equals ma. It's just now it's F centripetal equals ma centripetal. So I found that the centripetal force was 216. I doubled it. That gave me 432. I then put it into this equation here. 432 equals 6 times AC, and AC is going to equal 72 meters per second squared. There we go. Let's see, number 2. Let's move us up a little bit. Number 2. Alright, I have a string. Maximum tension force is 240. And what I want to know is what is the length of the string. So I'm going to use my centripetal force equation. This is the tension at which the string breaks. This is the mass of the object that's being spun around. 22 meters per second is how fast it's swinging, and I want to know what is the length or radius of the string. And so when I solve this, I get 6.05 meters. Quite a long string, I must say. Alright, now let's try number 3. Now, this is a category of question you should get used to. It's a skidding car question. These are classics. Okay, so basically, I have a 350 kilogram car. It's going to go around a curve with this radius. And here's what I know about it, is that the coefficient of friction between the car and the road is 0.45. So the first thing I got to do is figure out what is the friction force, because that's going to supply the centripetal force. Remember, centripetal is not a kind of force, it's a direction of force that's caused by ordinary sources of forces, like friction, gravity, tension, and so on, and normal. So what I have here is I'm going to use the friction force equation. If you've forgotten it, it is the force of friction equals mu, which is the coefficient of friction, times the normal force. So in this case, mu is 0.45. The normal force is mg. So there's my m. Remember, g is 10, so I get an mg of 3,500. So therefore, the friction force that's acting on the car is 1575. That's the most I can get out of it. So I say 1575 is the force that's going to cause the car to turn. Here's its mass, here's the curvature of radius, and I want to solve for the maximum velocity, and that's 10.6 meters per second. So watch out. This next one, I guess you bought this car in Gorst. Alright, so I have this car door, it's held shut with duct tape. The car door has this mass, and I want to know what is your mass. And this is how much force the tape is holding it closed with. So once this force is exceeded, you fly out of the car. So I have 1100 newtons equals your mass plus the 25 kilogram mass of the door combined times the velocity squared divided by the radius of curvature. So I've got to solve for the m, which is part of the mass. So when I solve for it, I get 43.4 kilograms. I trust you can resolve this to get this. The trick was just to remember that the total mass is 25 kilograms plus the rider's mass. Alright, so now number 5 says I have an object with 20 kilogram mass. The object B has 40. So if I want them to have equal amounts of centripetal force, how many times faster should this one have to go than this one? In other words, I need to double the centripetal force of this one. So how many times faster does it have to go? Basically, I want to double the centripetal force using velocity, so basically I take the square root of 2. So I'm going 2 times faster, but it's velocity squared, so I have to square root it. I get 1.4 times faster. And then the next question is asking if I have the same two objects, half the mass, twice the mass, are swung at the same speed with ropes of equal length. So basically what we're asking is what is the effect that mass has on centripetal force, and the bottom line is since B has twice as much mass, it will have 2 times as much centripetal force acting on it. Okay, so what I've got here is a spring with a 1500 Newton meter spring constant. It's a massless spring, by the way. Love those. Swinging a 2 kilogram mass around in an arc. And so as this thing spins, the rope stretches, It kind of goes. All right, and so here's what we've got. All right, first thing I got to do is I've got to take the fact that the spring at rest was 0.12, and it stretches to 1.2. It stretches to 1.6. So the difference is 0.4. So I'm going to recall that spring force equals K times X, where K is the spring constant and X is the amount of change in the length of the spring. So 1500 times 0.4 gives me 600 newtons of force. Well, that force is essentially the centripetal force, because it's going it's going equally in both directions. So this direction here would be the centripetal force. So I'd say I'm just going to take this value and put it into the centripetal force equation, 600 newtons. In other words, the centripetal force in this case is being supplied by the spring force. So 600 newtons equals 2 kilograms of mass divided by the length of the Oh darn it, I just remembered that when I wrote this problem I decided to include the length of the sides of the mass. So this value here is wrong. Let's change it. It's not 1.6. It's basically going to be half of 20, so I have to add that to it, so it's 1.7. So that's going to change this to 22.6. So the answer should be 22.6 meters per second. Okay, so now I have the Gravitron problem. Alright, so the first thing I've got to do is I've got to figure out what is the amount of centripetal force needed to keep Dad from falling to his doom. So I'm going to remember that the force of gravity in this case on a 65 kilogram Dad is going to be 650 newtons pulling down the wall. So I need to have a force of friction equal to 650 newtons acting up the wall to keep him in place. So I'm going to use the friction equation. So the force of friction equals mu force normal. Now the force normal in this case is being supplied by the wall of the Gravitron, not by the floor. So I say, well, 650 newtons of force, of friction force, is going to equal 0.3 times the normal force. So when I solve for the normal force, I get 2166.7. So that's how much centripetal force it's going to take acting inwards to produce enough friction force to keep Dad from falling. So I take this force here and use it in my centripetal force equation. This normal force is supplying the centripetal force. Dad is 65 kilogram dude. The Gravitron has a radius of 6 meters. I'm going to solve for velocity, so velocity squared. I'm going to solve for velocity. I get 14.1 meters per second. Now, if you do the same thing for the sun sitting next to him, it should be no surprise that the sun is fine too, because when you do the math for the kid, you're going to get the exact same value. And the reason is because basically the normal force is dependent on the gravitational force of the kid, which was dependent on his mass. And the centripetal force is also dependent on his mass. And so as a result, whatever velocity it takes to keep one person on that ride glued against the wall is true for all of them. Okay, so now I have the tetherball problem. Alright, so what I've got here is A, first of all, what is the radius of the circular path of the ball? So I want to solve for this value here. So what I'm going to do is I'm going to take the, now ignore this, I decided to do it a different way. So I have 1.8 meters in length. This is the opposite side to this angle. So since this angle's opposite is here, I'm going to use sine. So 1.8 times the sine of 32 gives me this distance here, which is 0.95 meters, which is the radius of the circular path. Now if I want to know the tension on this rope, what I know is that I have the force of gravity is pulling down on this tetherball with 30 newtons, so therefore I need to have an upward force of 30 newtons, and that upward force of 30 newtons can. So let's just do it this way. Let's just say that what we're looking for then, this value here is the same as this one here, so this is going to be the cosine of this angle. So I'm going to say the tension, which I'm looking for, times the cosine of 32. I used the sine of 58 the first time. Same thing. The cosine of 32 is going to equal 30 newtons. And that gives me a tension force acting on the string of 35.4 newtons. So now I want to know what the centripetal force is. Well, if you think about it, the centripetal force is basically going to be equal to whatever force is pulling this ball out, because the forces have to be equal in both directions. In a sense, it's in dynamic equilibrium. So therefore, what is the centripetal force acting on the ball? I'm going to take the tension on the rope, 35.4. Now I'm going to say this is the opposite of this angle, so I'm going to use the sine of 32, gives me 18.8 newtons. So 18.8 newtons are acting this way, therefore 18.8 newtons are acting that way. Therefore, how fast is the ball moving? I'm going to use the centripetal force equation, and I'm going to say 18.8 newtons equals 3 kilograms times the velocity I'm looking for divided by 0.95, and when I solve for v, I get 2.4 meters per second.